In this video, we're going to look in more detail at the costs of different components of a piped water and sanitation system. First, we will use cost per cubic meter as our unit of analysis. Then we will use these volumetric costs to estimate cost per household per month. This table shows 7 cost components of a piped water and sanitation system. The first component is the cost of the raw water supply itself. If a city has to pay a farmer for water that is now being used for irrigation, this will represent the cost of the raw water supply. Alternatively, if a desalination plant is required to transform seawater into fresh water, then the desalination cost per cubic meter will be the cost of our raw water supply. Even if a community doesn't pay a monetary price for its raw water supply, it may impose an opportunity cost on others by taking it. The second component is the cost of transporting the raw water to the city and storing it. This cost component may be negligible if raw water supplies are nearby, or may be substantial if supplies must be transported many kilometers to a city. If reservoirs are needed to store drinking water near a city, these costs can be substantial. The third component is to treat the water to potable standards before distribution to households and businesses. Raw water treatment can be very simple, just simple chlorination. Some raw water supplies may be so clean they don't even need any treatment at all. But on the other hand, water treatment can be quite expensive. For example, if heavy metals need to be removed from the raw water supply, treatment costs may go up substantially. The fourth component is the water distribution network to carry the water from the water intake treatment plant to homes and businesses. The fifth cost component is the sewer network to collect wastewater from homes and businesses and carry it to the wastewater treatment plant. The sixth cost component is the treatment of the wastewater collected. These costs can vary widely depending on the constituents of the wastewater stream, the characteristics of the location, and the standard of treatment required. The seventh cost component is any remaining damages associated with the discharge of treated wastewater. Households in the service area may not bear these costs. They fall on people downstream of the treated wastewater discharge. The more wastewater treatment is done, the lower these damages. Which of these 7 cost components do you think are largest, and which are the smallest? Of course, these costs will vary by location, but what do you think would be a typical allocation of the total cost of the 7 components in the table? This table shows some illustrative costs per cubic meter for each of the 7 components. I have assumed here that the city is sufficiently large to capture significant economies of scale, much larger than the Hopi villages we saw in our earlier video. In most cases, the big cost components are the sewer network, followed by the water distribution network. These 2 components are usually from half to 2/3 of the total cost. The next big component is wastewater treatment, depending of course on the desired quality of the treated wastewater. As shown in the table, the total cost for all 7 components are on the order of $2 to $3 per cubic meter. The transport and storage of raw water supplies can be expensive in some cases, but many cities are able to find relatively inexpensive raw water supplies. I want to emphasize that this is not an upper bound on the cost per cubic meter. The costs where I live in the United States are approximately twice this much per cubic meter. How low could these costs of pipe network services realistically be? Let's do a simple thought experiment and assume that every one of the 7 components in the table is very low. First, let's assume that the first cost component is free. We live in a water-abundant area and get our raw water supply for nothing. Second, our raw water supply is nearby and doesn't require transport, just a simple overhead storage tank. Assume this costs 10 cents per cubic meter. Third, our raw water supply is very clean and requires only simple chlorination. Let's say this costs 5 cents per cubic meter. Fourth, let's assume excavation is easy and we live in a tropical area where we don't have to worry about water lines freezing, so we can lay shallow PVC pipe. Assume this costs 30 cents per cubic meter. Fifth, assume we build a small bore sewer system such as a condominial system. I'll describe this technology in a later video, but for now assume it's cheaper than a traditional sewer network, say 35 cents per cubic meter. Sixth, we only use a simple lagoon for wastewater treatment, like the Hopi villages. We do not build a modern wastewater treatment plant. Let's say the cost is only 20 cents per cubic meter. Seventh, let's assume no one lives downstream of our wastewater discharge and there are no damages from it. We still end up with costs of $1 per cubic meter. Now, to get a better sense of what costs per cubic meter mean at the household level, let's next look at how many cubic meters households with pipe connections typically use. The amount of water a household uses depends on several factors, including the number of household members. For purposes of illustration, let's assume 5 members per household and look at 3 fairly typical amounts of water used per capita per day. A person living in a household with a piped water connection will rarely use less than 65 liters per capita per day. A person without much outdoor water use will use about 130 liters per capita per day. And a person with significant outdoor water use, such as gardening or lawn watering, might use 270 liters per capita per day. So rich households or households with side businesses or livestock could use substantially more than this. In the table, I've multiplied these daily per capita water use amounts by the number of people in the household and the number of days in a month to obtain a range of monthly household water use estimates. My wife and I use about 10 cubic meters per month, but our children have left home and there are only 2 of us. It is quite common in developing countries to see monthly household water use in the 10 to 30 cubic meter range, but some households will use 40 cubic meters per month or more when they need water for outdoor or commercial uses. On this slide, we combine these estimates of monthly household water use with our estimates of the cost per cubic meter to estimate the cost per household per month. Let's first look at the cell in the middle. This case is for a household using 20 cubic meters per month. The services cost $2 per cubic meter, so the total cost per household per month is $40. At the low end, consider a household that only uses 10 cubic meters per month and uses water and sanitation services that only cost $1 per cubic meter. Now the total cost per household per month is $10. It doesn't get much cheaper than this to provide piped water and sanitation services to a household. At the upper end of the range, for a household using 40 cubic meters per month that uses US dollars per cubic meter of 3, the total cost per month will be $120 US. I'd like you to remember a conclusion from these calculations. It's not at all unusual for cost per household per month to fall in the range of $50 to $100 US for modern piped water and sanitation services in industrialized countries. But it's cheaper in developing countries, right? Well, yes it is, but not as much as you might think. People immediately think of labor being much cheaper in developing countries. And that's true, but skilled labor such as engineers is definitely not free. This figure shows that labor costs are indeed significantly cheaper in countries like India, Vietnam, and Uganda than they are in the United States and Europe. But remember that piped water systems are very capital intensive, not labor intensive. So this doesn't make as much of an effect on cost as you might think. This table presents a comparison of different types of construction cost in selected countries. The red shows the highest cost, the green the lowest cost. These construction costs are not specific to water and sanitation services. The column at the far right for construction of high-tech industrial factory laboratory is probably the best comparison. As you look over these global construction costs and the costs of inputs such as concrete and rebar, that's steel rod for use in reinforced concrete, note that costs are lower in developing countries, but there is a lot of variation. For example, rebar is very expensive in Brazil, and concrete is quite expensive in South Africa and India. I think the lesson here is that costs of water and sanitation services are somewhat cheaper in lower and middle income countries, but they are still capital intensive and far from free. It would be a mistake to assume that these services are expensive in industrialized countries, but not in developing countries. There's another cost of providing water and sanitation services that I'd like to call your attention to. This is the disruption to businesses and people's lives in general during urban construction. This picture shows a construction project underway in a neighborhood in Delhi, India. As you can see, the streets in front of the shops are quite a mess. Of course, this is not a reason to not install infrastructure, but it is a cost to be included when estimating the full cost of service. In the next set of slides, I want to show you some pictures from Kathmandu, Nepal, to give you a sense of the magnitude of the costs needed in a major city in Southeast Asia. This is an aerial view of Kathmandu that I took in 2001. At that time, the city had a population of about 1 million people. Today, the population has been estimated to be 3 to 4 million. On this next photograph, if you look closely at the rooftops of these buildings, you will see numerous water storage tanks. These tanks are needed because in 2001, many households only received water 2 hours a day for a few days a week. Today, the situation is much worse for many households, especially households not connected to the pipe network. Along this small street, the old water lines are exposed. These pipelines were probably installed in the 1960s, and today they're fully depreciated, like the Hopi water systems that we saw earlier. Here's a look at a pipeline repair project underway in a neighborhood. Notice the multiple pipelines laid next to each other. In most neighborhoods, there's no record of where the water and sewer lines actually are. Here's a closer look. In the 1990s, several international firms looked at this infrastructure to estimate what it was worth. Most concluded that it all had to be replaced. You couldn't put these pipes under any pressure, they would burst. These pipelines are all subject to negative pressure and water infiltration. This means that contaminated groundwater will get into the water in these pipes. So water from the pipes is not going to be potable. For 2 decades now, there have been plans for a new water source for Kathmandu. This is the Melemchi River. It has plenty of clean mountain water for the population of Kathmandu. The only problem is it's on the other side of a mountain from Kathmandu. And a 26-kilometer tunnel needs to be drilled through solid rock to get the water to Kathmandu. The total cost of the tunnel, plus a water treatment plant, plus bulk distribution and some network rehabilitation, is estimated to be about $500 million US. More money is needed to expand the distribution network and the wastewater collection system, and also wastewater treatment plants are needed in Kathmandu. So you can clearly see here the large amounts of capital required and the essential role of financing. I suggest you do some rough estimates to see what the Melemchi project would cost households in Kathmandu per month if they had to repay a loan for this project. To wrap up this video, I want to emphasize 3 main points. First, when you hear someone talk about the cost of piped water and sanitation services in a particular location, be sure to determine which of the 7 cost components they are including. You may hear people say clean water only costs pennies per month. Such statements usually come from analysts who are looking at just one of the 7 components, not the total cost. Second, when you review cost estimates for piped water and sanitation services, pay particular attention to what has been assumed about the financing and the cost of capital. Third, as Professor Loria discusses in his conversation with me this week, costs depend on a number of factors. They can vary a lot. But the total cost of all these components is often much higher than people realize, even in developing countries. If someone tells you that piped water and sanitation services can be delivered for less than $1 per cubic meter, you really need to look carefully at these estimates. It is likely that the true cost is $2 to $3 per cubic meter or even higher. In the next video, we will look at the cost of non-piped water and sanitation infrastructure.